So the basic next question is there a way to avoid the overshoot? And it would be nice if we could do this, because driving in an oscillating car is no fun. In fact, it makes you really seasick. Believe me, I've been in this car for months on end when we prepared for the DARPA Grand Challenge. And the trick is called PD control. In PD control, my steering alpha is not just related to the cross-track error by virtue of the gain parameter tau p, but also to the temporal derivative of the cross-track error. What this means is that when the car has turned enough to reduce the cross-track error, it won't just go shooting for the x-axis, but it will notice that it's already reducing the error. So when the error is becoming smaller over time, it counter steers. It steers up again. And this will allow it to gracefully approach our target trajectory, assuming appropriate settings of our differential gain tau d versus the proportional gain tau p. How do you compute this derivative over here? Well, at time t, this is the same as the cross-track error at time t minus the cross-track error at time t minus 1 divided by the time span between t and t minus 1. In our code, we assume delta t equals 1, so we can omit this. So the difference of the current cross-track error and the previous one is this term over here. And we now control not just in proportion to the error itself, but also to this difference of the error using a second constant tau d. So let's implement this. Now I give the one command two parameters, param1 and param2, and I want you to implement a controller that varies the steering direction proportionally according to parameter 1 and differentially proportionally to parameter 2. Again, run for 100 time step and see what happens. So when I run my new controller with proportionality parameter of 0.2 and the differential one is 3.0, then I get a sequence of y values that converge much more gently to 0. And miraculously, as time goes on, they really go down to 0 and stay at 0, which we didn't achieve for the proportional controller. So please write that routine so we can test it.